Any student can ask us doubts in our Telegram group, Takshzila Study Circle, the link of which is in the description below. Amongst the doubt asked, a few selected ones, those which are a little application oriented and not direct, simple theory based. We discuss them here. However, disclaimer, while will make your time on the social media worth it, do not consider this as your primary CAT preparation source. For us, these are more like marketing videos to showcase our teaching style and to pass on some information. And one information that I have today is, with a lot of students insisting or asking us for a course with live online classes, we are heeding to the requests and we are starting one batch with live online courses. Earlier we were not going to do because our course with recorded concept videos is very nice, but then the requests kept pouring in and a lot of students want course with live classes, so we are starting one. The link to the course, the description is again given below. So please go ahead. If you do want a course with a live online class, check that out or pass on the information to someone who likes, who needs them, right? The details are there, so I'm not speaking them here. Let me directly go ahead with the today's doubt question. So find the smallest value of a number n such that 2n by 27 is a perfect square, 4n by 4 is a perfect cube. So for those who know this, it's not a very difficult question, but for those who are not aware of it, one would ponder what one needs to do. So we need a perfect square, we need a perfect cube, and that n is changed. It's multiplied with 2 divided by 27 and so on. So if you see the numbers involved, 2, which is 2 raised to 1 itself, 27 is a 3 cube, and 9 is a 3 square, 4 is a 2 square. So what's happening is when we multiply or divide by a 9, 2, 27, 9, 4, we are essentially changing the powers, the index, changing the power of primes 2 and powers of 2 and 3. The primes 2 and 3. So the start could be that we just need to focus on the powers of 2 and 3. So let's assume the number n as 2 raised to a into 3 raised to b. That could be further primes also, 5, 7, 11, but we need the smallest value. So why do we need to get those 5, 7, 11 involved? Let's say their powers are 0, so that the number is small. Why do we need the powers of 2 and 3? Because they are going to be changed, because we do 2n by 27, 9n by 4. So that is what the next thing you have to do. So if you take 2n by 27, so in the factorized form, n is multiplied with a 2. So the power of 2 is now going to be a plus 1. The power gets increased. And it's divided by 3 cube. So when you divide by 3, you are essentially going to subtract 3 from the index. So this is your 2n by 27. And we know that this number is given to be a square. And if it is a square, this is the application part where we have, right? If it is a square, you need to know that the index have to be multiples of 2. All index have to be of the form multiple of 2. That is the time then it is going to be a perfect square. So our next step is going to be, so a plus 1. Now this is a plus 1. So this whole number will definitely be more than 1. So power multiple of 2 more than 1 which could be 2, it could be 4, 6, 8 and so on. It could be any larger number. And this is the value of a plus 1. So from here we can get the value of a as, subtract a 1, it could be 1 or a 3 or a 5 or a 7. The series is a simple number. So for this condition to be valid, 2 raised to a plus 1 should be a part of a square. A can be any odd number. Similarly, B minus 3. So we are subtracting a 3. So it could also become end up as 0. So this could be a 0 or a 2 or a 4 or a 6 or so on, any larger multiple of 2. And which tells me that the acceptable values of B is add a 3. So add a 3 to each of them. So 5, 3 and 4 is a 7, 6 and 3 is a 9. So these are the values, again odd values, but B can't be 1 because if B is 1, this will become a negative, and if it is negative, it's going to be in the denominator. We don't call them as perfect squares. So we have these values and their possibilities. Why am I talking about the different possibilities? Because we have multiple conditions. There's one more condition. Okay, and between the two conditions, I'll just check which are the common ones. So now I look at repeat, and now you should be able to do the next thing on your own. So repeat it and finish it off yourself if you were not sure how to have done it. Students, watching the full solution isn't any great help. Okay, this time we are dividing by 2 squares, so the power of 2 will get reduced by 2. We are multiplying by 9, so the power of 3 will increment by 2, and this is a cube. And because it is a cube, the indices, the powers have to be of the form a multiple of 3. Same logic, so this is, we are subtracting a 2, so it could end up at 0 also. So 0 or 3 or 6 or 9 or so on, any multiple of 3, which tells me that the value of A is add a 2 or a 5 or a 8 or 11, and so this is an increase of 3. And B plus 2 can be a multiple of 3. It has to be more than 2. Okay, so more than 2 could only be a 3 or a 6 or a 9 or a 12 and so on. Subtract a 2 from both sides, so this gets a subtract a 2, subtract a 2, subtract a 2 and a 10. So this is also increasing by 3 here. 1, 4, 7, 10. So these two conditions both have to be met. So if both, I have to meet both this as well as this. So at the same time, remember, we need to choose the smallest value for A indices also. That would make n as the smallest. So 1 is not present here, 2 is not present, 3. So you see a 5 is present in both. So A being 5 will satisfy this as well as this. A 1 is not present here, 3 no, 4 is not there, 5 is not there, 7 is the smallest number which is present in both the list. Usually these which are present should be found in the first few values. If they can't, then it becomes another question of finding a common term for two different APs. Yeah, but that is for some other question. You won't find it needed in such small questions. So the smallest value of n that we can come to is 2 raised to 5, 3 raised to 7. And this is my answer.